Today we're going to figure out how to take a second degree function and put it in what we call vertex form. And vertex form looks like this. Y equals, we have a coefficient. If there's a coefficient greater than 1, that would be our a value, and then we have our variable x minus h plus k. You've seen this form before with circle equations, and you might have done vertex form before in Algebra 2 trig. The vertex is called vertex form because we can directly read the vertex from here. If you think about your transformations, and you think about a parabola, it normally has its vertex at 0, 0. A transformation of minus h and plus k would shift this to the right by h units and up by k units. So the new vertex would be h comma k. So once we put a function in vertex form, we are directly able to read the vertex. Now, the rest of this lesson is going to be focused on how we do that. How do we go from standard form to vertex form? Remember, standard form is y is equal to a x squared plus bx plus c. So we're going to start here and end here. And to do that, we have to do something called completing the square. Alright, so here's our function that's in standard form, 2x squared minus 12x plus 23. And I'm going to put it in vertex form by completing the square. Completing the square is the process of creating a perfect square trinomial that factors into the same thing twice. Because if you think of our vertex form, remember that we had a squared term in parentheses with the added constant on the outside. So the first step would be, if we have a coefficient greater than 1 in front of my x squared term, I need to factor that coefficient from the x squared and the x term. So that's what my first step is going to be. In this case, I'm going to change f of x to y. I have 2 is equal to x squared minus 6x. And then the 23 is just along for the ride until the end, but I'm going to separate out my first and second degree terms from my constant term. So the next step is this completing the square process. And I'm going to walk you through this. In order to do this, I'm going to rewrite my function y is equal to 2, and then here's what I'm going to do. I have x squared minus 6x. I need to add something in here to make it a perfect square trinomial, so it factors into the same thing twice. Now I still have my 23 out here. However, in order to not change the meaning or the value of this function, if I add something here, I have to subtract it away out here. But we have this 2 in front. So what I'm really subtracting away is 2 times whatever value I have in here. So I have plus 23, and then I have to subtract away a 2 times whatever number I put in here. So in order to find that number, you got to divide the x coefficient in half. So you divide the x coefficient by 2, and then you square it. And that's what's going to go in the blank. So my x coefficient is 6. We ignore the sign right now. My x coefficient is 6. So 6 divided by 2 is 3, and 3 squared is 9. That's what's going in there. If I add the 9 there, see, if I add the 9 in here, I got to take it away out here. 9 times 2 is 18, so I got to subtract away 18. That way it doesn't change the meaning of my problem. Finally, I have to factor my perfect square trinomial and simplify my expression. X squared minus 6x plus 9. It should be pretty easy to factor. So I have my y value, or f of x. I have 2. And then what this thing is going to factor into is the same binomial squared. It's the square root of x squared, it's the square root of 9, and the sign of the middle. So x minus 3, quantity squared. On the outside, I have 23 minus 18, so that's going to leave me with plus 5. Now we have our function in vertex form, and I can name the vertex. The vertex is going to be 3, 5. So that's the process we're going to use to put a function in vertex form. Alright, so let me demonstrate with another example. F of x is equal to negative 4x squared minus 16x plus 3. And we want to place this in vertex form. So the first thing I have to do is to factor whatever coefficient I have out here in front of the x squared, factor it out of the x squared and the x term. That's going to look like this. F of x is equal to, I need the negative 4 factored out, because you want your x squared term positive. When I factor negative 4 out, that turns into x squared plus 4x, and then the 3 is on the outside. Now what I should have done, you can do this in one step. When I factor it out, I'm going to put a blank in for the completing the square part. Plus blank, plus 3. Now, let's think about this. Whatever I add here, I'm going to multiply by negative 4 and subtract away. So plus 3 minus a negative 4 times whatever value I have. And then it'll all work out. Okay, I take the 4, I divide it in half, and that's 2, and then I square it and put it back in. That's going to be a 4, and that's going to be a 4. And now I simplify. F of x is equal to negative 4. This thing is going to factor into the same binomial twice. It's going to be x squared plus 2. The square root of the first guy, the square root of the second guy, the sine of the middle. And then on the outside, I have plus 3. And when I simplify this guy, I have negative 4 times negative 1 times 4. Well, this is negative 16 that I'm subtracting away, so it's addition, plus 16, which means my final answer is negative 4 x plus 2 quantity squared plus 19. From there I can read the vertex. It's negative 2, 19. So that's the process we need to use to place a value in vertex form.